What if the most advanced solar observatory on Earth isn't owned by NASA, but was carved into stone 1,500 years ago? We have been cross-referencing ancient Mayan stele with cutting-edge heliophysics, and what we found challenges everything you thought you knew about the boundary between prophecy and science. The mathematics shouldn't be this accurate, yet the data matches almost perfectly. Today we journey into one of history's most extraordinary intersections. The moment ancient astronomical genius meets our most urgent modern crisis. We'll uncover how a civilization without telescopes, without satellites, and without computers mapped the deep rhythms of the sun across thousands of years, and why that knowledge may matter more right now than at any point since it was first carved in stone.
Let us begin on January 19th, 2026. On that single day, Earth was struck by one of the strongest geomagnetic events ever recorded. In the 28-year combined monitoring history of NASA's C and Descobar satellites, power grids flickered, satellite communications degraded, emergency managers opened contingency plans. And yet, for most people on Earth, the morning looked like an ordinary sunrise.
That disconnect between what the sun was doing and what we were prepared for is the heart of our story. Because the sun is not a stable, polite neighbor. It is a volatile, cycling star whose outbursts follow patterns operating across timescales far longer than the 70 years our satellites have been watching. Here is what we are truly up against. NASA's Deep Space Climate Observatory, DISCOVER, sits 1 million miles from Earth at the L1 Lagrange point. When a coronal mass ejection, a billion-ton plasma eruption from the sun, crosses DISCOVER's sensors, it typically reaches Earth between 15 and 60 minutes later. That is our entire early warning window. To understand what that means, consider 1859. The Carrington event, a solar superstorm so powerful it sent electrical currents surging through telegraph lines, electrocuting operators and spontaneously igniting papers across North America and Europe. A modern equivalent is estimated to cause up to $2.5 trillion in damage to United States infrastructure alone, with recovery measured in years, not weeks. The Maya built in limestone. Their civilization's most critical records survived a millennium. Ours would not survive a fortnight without electricity. And this brings us to the carved stones of the Yucatán Peninsula, and a question historians and physicists are only now beginning to take seriously together. The ancient Maya were not mere stargazers. They were systematic mathematicians whose celestial record-keeping rivaled and in certain respects surpassed the precision of early modern science. Their calendar was not a single reckoning of days, but an interlocking architecture of multiple cycles. Consider the Haab, a 365-day solar calendar that accumulated an error of just one day every 6,729 years. The Gregorian calendar we use today drifts one day every 3,236 years. The Maya were more than twice as accurate, and they achieved it through pure, patient, generational observation. But it is the long count calendar that commands the deepest awe. Its grand unit, the 13 Baktun Great Cycle, spans approximately 5,125 solar years. 5 such great cycles closely approximate the 25,000-year precession of Earth's own axis. The Maya were not just tracking the sun's annual behavior, they were mapping the slow geological wobble of our planet across deep time. The evidence for their sophistication does not stop with numbers. Among only 4 surviving pre-Columbian Maya manuscripts, the Dresden Codex stands apart. This 11th century document predicts Venus's cycle to within a single day across centuries, and contains eclipse tables spanning 405 consecutive lunar months. A model scholars have confirmed was iteratively corrected through direct sky observation across generations. The Maya were doing empirical science: observe, record, compare, adjust, predict. They built that knowledge into the landscape itself. The Caracol at Chichen Itza, named for its spiral interior staircase, is recognized today as a purpose-built astronomical station, with windows precisely aligned to Venus's extreme positions and solar sunset points at the solstices. At El Castillo Pyramid, on the spring equinox, shadows on the northern staircase create the unmistakable illusion of a serpent descending from sky to earth, an effect achievable only through precise solar angle engineering. Now, here is where ancient cosmology and modern heliophysics begin to speak the same language. In Mesoamerican thought, humanity has passed through 4 previous cosmic ages, each ended by catastrophic transformation. The current era, the 5th sun, was tied to the long count's completion on December 21st, 2012. Not apocalypse, completion. The close of one great cycle and the opening of another. What is remarkable is that this framework of periodic cosmic reset aligns with documented paleomagnetic records showing 5,000 to 6,000 year cycles in Earth's magnetic field behavior. Earth's magnetic field has already weakened by approximately 9% over the past 170 years, a trajectory geologists associate with potential geomagnetic excursion. Ancient cosmology and satellite data are, in this moment, pointing toward the same concern. The Maya even institutionalized behavior around their most dangerous calendrical periods. Those 5 transitional days at the end of the Haab, called the Wayeb, were treated as cosmic peril. Fires were extinguished. People avoided public spaces. An entire civilization adopted a coordinated, calendar-triggered social protocol around a window of anticipated celestial danger. That structural parallel to a modern space weather agency issuing a G4 or G5 storm watch is not poetic coincidence. It is functionally identical. And consider this final, humbling irony. NASA's own Solar Cycle Prediction Panel forecasts Solar Cycle 25 as a weak, quiet event. Instead, it became one of the most active cycles in decades, exceeding every expert model. The civilization working from a satellite baseline of 70 years was caught off guard. A civilization encoding solar patterns across great cycles of 1,500 years of continuous observation might not have been. The Maya Venus tables were not calendrical poetry either. Maya kings launched military campaigns based on Venus's heliacal rise, converting celestial prediction directly into real-world strategic decisions. The instinct to act on astronomical data, to govern by the sky, was not primitive. It was advanced. History is rarely just about the distant past. Sometimes it confronts us with the urgent question of what those who came before truly understood, and whether we are humble enough to listen. The Maya looked up at the same sun. They ran the mathematics. They carved the answers in stone. What would it mean if the most actionable solar forecasting framework on Earth had already been written, not in a satellite uplink, but in the limestone of the Yucatan? That is the question I leave with you today. Share your thoughts in the comments below. And if the past has something to teach us about surviving the future, stay with me, because we are only just beginning.